Okay, gentlemen, this is going to be the video for our study guide, okay? One thing I do want to note that this is a study guide, and as it kind of mentions in the name, this is just meant to guide your studies and preparations for the test. Um, as I state at the top, this will not be everything that is on the test. For example, these questions that I've written down are going to look different and probably be different. The questions on my study guide are to give you an idea of what I expect you to be able to do. Okay? Especially with this topic, it's sort of almost black and white. Like, it's not like in algebra I could just change some numbers. I'm going to have to ask you different questions, and it's really going to show you a mastery of the content if you're able to score well. So, the following things are fair game. So, inductive reasoning, this is pattern recognition. Gauss's method for summing integers. If you don't remember this, this is most likely going to appear as a bonus, okay? I'm telling you that, but don't spend 3 hours memorizing Gauss's method for summing integers. I think it would be more beneficial for you to look at other things. Conditional statements are on there. So with a hypothesis, conclusion, converse, inverse, and contrapositive. We have negation. So remember what the negation symbols are and how negation works with everything. We have conjunctions and disjunctions. That's the ands or the ors. De Morgan's law, and then lastly biconditional statements. Okay. So now I have be prepared to write truth tables dealing with if-then statements, if, which that means if and only if. Remember that. This is if and only. Oops. Only if. Conjunctions, disjunctions, biconditionals, as well as combinations of all of these. So what this is going to look like is what this combinations is going to look like. I think I have it noted too. Homework from Tuesday, as well as classwork Wednesday. Okay, so homework from Tuesday, classwork from Wednesday, and then I also have here be prepared to answer some true, false, multiple choice, matching questions. So it might be a little bit of everything on there. Now, let's go ahead and get into it. So for number one, use the following conditional statement to write the following. So I have all these different things, and our statement is if I go to the store, I will buy a game. Okay, so when I have a conditional statement, the first thing I'm going to think of is I'm going to break it into two parts, my P and then my Q, and this Q goes down to here, and this is a typo. There should be a then in here. Hopefully I'll get this fixed by tomorrow. I apologize for that. So writing the hypothesis, remember the hypothesis is the beginning part. So this is I go to the store. So that is the part after the if. The Q, or the conclusion, that is the part after the then. So I will buy a game. If we're negating, all we're going to do is say essentially the opposite. So I won't go to the store. And then I won't buy a game. Now, when we're talking about the converse, the inverse, and the contrapositive, our conditional statement is P and Q. So if P, then Q. The converse is going to be if Q, then P. The inverse is negating our conditional, or negating each part, I should say. And then lastly, the contrapositive is flipping the inverse. So it's just a series of negating and then flipping things. Then all we're going to do is, just write it out. So now we're going to do the Q first. So if Q, so if let's use a capital letter. If oh my goodness, I buy a game, then I will go, I cannot write, to the store. And remember, these statements don't have to be necessarily true or make sense. Conditional statements and their inverses, their converses, their contrapositive, they don't necessarily have to make sense. It's just flipping the order things that go. So now writing the inverse, it's going to be the inverse of the conditional statement. So it's going to use the negation. So if I don't go to the store, then I won't buy a game. Then lastly, the contrapositive is not Q, not P. So if I don't buy a game, then I won't go to the store. So that's all that is. It's just writing sentences. Okay? So now I ask you to use this information with the conclusion and the hypothesis to write a conditional statement. So my conclusion is I will pass, and the hypothesis is I study. Remember, I'm trying to trick you here. Hypothesis goes first, so it's if I study, then I will pass. Okay? So now I ask you to write a conditional statement, and then write the contrapositive. So let's think of a conditional statement. If I drink water, then I will be hydrated. So that's my conditional statement. So this is if P then Q. And now the contrapositive is this one, remember, it's this. So it's not Q, or if not Q, then not P. So if I am not hydrated, then I didn't drink. Then I didn't drink water. So, easy enough. This sort of stuff we did, it's in the packet. You'll have another, set of them on here that you will have went through with creating these conditional statements, the conclusion, this, that, and the other thing. The other thing I encourage you to do, if you really need practice with this, just go open up a book. Open up the geometry book. I'll let you take it home. I'll let you borrow it. Or come in the morning and just do some of the practice problems that are in there. Please, for the love of God, do some practice problems if you don't know. Excuse me. So let's talk about De Morgan's laws. So this is, we did one of these in class and I assigned one of them for homework. And De Morgan's law deals with the negation of conjunctions and disjunctions. So it basically states that not A or B, or P or Q, whatever you want to say, this is equivalent to not A and not B. Or on the flip side, we have not A, and B. That's equivalent to not A or not B. So we proved one in class, then one for homework. I would like you to be familiar with these and how we proved them. I might have you guys write sentences with them. If I say, apply De Morgan's law, I might have you do something like that. We'll see. Just a little hint for something that might come. That's really it for this. I would go back and look at truth table. So why don't you just look at the truth table, refresh yourself and how we set that up. Remember when we're proving and looking at things like this with conjunctions and disjunctions, it's helpful to look at both of the individual. You know what? Screw it. Let's just do one of them. Let's look at this one. Okay. So we're gonna have A and B, and this is gonna be our our two variables. So this could be P and Q, whatever. So a few things that are going to be really necessary to have in this case. So if you look at all the little components of everything that we're doing with the first one, we have A or B. That's going to be important to know. So A or B. Why is that important to know? Because that's going to help us really quickly find what A or not A or B is. Excuse me, the not A or B. Now, the other things that are going to be really useful to know is not A not B, and then lastly, we're gonna have this not A and not B. Okay, so I'm filling out our truth table. Very simple to start. True, true, false, false, true, false, true, false. If we're dealing with or, we have or. We're looking for just one of the A or B to be true. So we have true, 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 and true. So all these are going to be true, 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 and true. Since we have false, false, that is going to be false. Remember, or, we just require one of them to be true. And we require both. Now, if I am going to say not A or B, it's going to be the opposite. So it's false, 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 true. It's the opposite of what we have. Okay? Now, we have not A and not B. So that's just going to be the opposite of A. Then the opposite of B. Oops. So now, oh, I messed something up. Where did I mess it up? Oh, no, I didn't. Oh, my goodness. Excuse me, my fault. So now we're looking at not A and not B. I don't know what I was thinking, but I think my mind was in biconditionals because I'm looking at the two F's and thinking that should be true. But that's not true. So now the only way that this statement is going to be true is if both not A and not B are true, and that only occurs at the bottom. So it's true, false, like this. Apologize for that. So now what we have to do is wrap this up. We look at what we're trying to prove up here and we look at our truth tables and they're the same. So we could say because not A or B and not not A and not B have the same truth value, TV. Remember, this is truth value. They are logically equivalent. Beautiful. So that's that. That is De Morgan's law. That's one of them. This is the other one here. So improving this one, it's pretty much the same thing. You're going to set the truth table in the same way. You're doing the same process. So let's look at our next one. So this is going to kind of look like what we did in class the one day with our playing cards and the odds and evens and the vowels and that sort of crap. So there are 4 suits on playing cards. We have spades, clubs, diamonds, and hearts. There's a rule that I've created. So if we have a red card, which is a diamond or a heart, so diamond/heart on the other side of the card, then there must be a vowel. So we could write it like this. We could write if diamond/heart, then why did I write a B? I should write a V for vowel. Okay, so that is kind of our conditional statement in which we look at. So now I ask, which cards do we have to check to see if the rule holds? So let's exhaustively go through this list. So first things first, I have a spade. My rule talks about diamonds and hearts. So it does not matter if what's on the other side of a spade. Doesn't matter. So we do not have to check this. Do we have to check the E? So let's think about what E is. E is a vowel. Now think about on the other side of the card. If I flip the E over, on the other side of the card, what would invalidate my original statement? Something that would invalidate my original statement is pulling a spade or a club. So we do have to check E. So E, because if there is a spade/heart, this would invalidate our conditional statement. Okay, cool. So we do have to check E. Let's think about a diamond. We do have to check it on the other side to make sure that there's a vowel. So our diamond, we have to check to see if there is a vowel. And then lastly, the 7. So would we have to check the 7? So you think about it, be like, oh, 7 doesn't have to do with anything. But with the E, it's the same line of thinking. If I flip over that 7, what would invalidate my statement? If I flip over that 7, and there is a diamond or heart, essentially a red card, then that would break this. So we need to check for diamond/heart, because that would invalidate the conditional statement. Okay? Very good. So now, that is all we have to do for this. We have to check are are the E, the diamond, and the 7. We don't have to check the spade. Next, be familiar with the following truth table. Know when things are true and when they are false. So I gave a few examples, and one of them that I've really grown to like is, let's say, if I play football, then I play a sport. So this is our P, this is our Q, okay? And we want to make sure that all of these different combinations of all this stuff invalidates or validates our statement. So if they're both true, we're going to have this statement, if I play football, then I play a sport. That is exactly the same statement, so that is true. Okay? Next, if I play football, then I don't play a sport. That directly invalidates my statement. I'm saying if I play football, you have to play a sport. And now, with this false here, I'm saying, oh, I don't play a sport anymore. And we know that that is not true because of our conditional statement. Next, if I don't play football, then I play a sport. This doesn't invalidate this. So it's still true. Think about it like this. If I draw a Venn diagram and I have, I have sport and I have football. So football is in the realm of sports. But if I play, let's say I play baseball, okay? Baseball's still a sport. And that would, we could substitute that in for this. So if I play baseball, then I play a sport. That doesn't invalidate this, okay? The other way you can think of this is, well, actually, I'm going to leave this here, is that our original statement is talking about football, okay? If over here I'm not talking about football, I'm talking about either a different sport, I'm talking about quote-unquote not football, like the negation of football, so like not F or not P for not football. I'm not talking about that in my original sentence. So there's literally nothing that I can contradict with because I'm not talking about it anymore. I'm talking about baseball now. That's not football. So if I'm talking about baseball, how could that contradict my statement about football needing to be a sport? So that's another way that we could look at this. And that's how I like to look at the last one. If I don't play football, then I don't play a sport. You could think about this like statement. It's like, oh, well, what if I play baseball? It doesn't matter because we're not talking about football. We're not talking about football anymore. And our original statement talks about football. Okay? So that's one way that I like to view it. If your first part, your hypothesis, is false, you are always going to have true. Okay? And then if they're both true. I would suggest you memorize that if you are still not getting it. Another way that I like to think about this is in totally arbitrary examples. Stuff that has no relation to each other. So, like, if I chew gum, then Germany win World Cup. Okay? You know those two things have no correlation with each other. Let's think about it. So this is my statement. If I chew gum, then Germany will win the World Cup. If they're both true, that's still our original statement. So that kind of validates this. I'm saying in my statement, if I chew gum, then Germany will win the World Cup. Now, if I say, if I chew gum, then Germany won't win the World Cup, that is a direct invalidation of this. So that has to be false. So that's correct. Now, if I don't chew gum and Germany won the World Cup, that's still okay. Remember, it's not necessarily whether it's true or not, it's whether the statement that you create with this false and true invalidates our original statement. So if I don't chew gum and Germany win the World Cup, that's still okay. It doesn't invalidate it. Because now we're no longer talking about chewing gum. That's the other thing. We're talking about chewing gum up here, and now I'm saying I'm not chewing gum. It could be a number of things. It could be maybe I'm eating a pretzel. It could be maybe I'm, drinking water. Maybe I'm making dinner. Maybe I'm doing whatever, but I'm not chewing gum. And our original statement says I have to be chewing gum, and then Germany wins the World Cup. If I'm not doing that anymore, if I'm not chewing gum, I'm not contradicting my original statement. So this is true. And then going off the same line of thinking, if I don't chew gum, then Germany don't win the World Cup. Once again, I'm not talking about chewing gum anymore. So it doesn't matter. This is something that I might look for maybe another explanation, another YouTube video with someone who might have a slightly alternate explanation that might resonate with you a little bit more. But this sort of the I play football, this over here, as well as just an arbitrary example, are some things that some students have sort of latched onto. Okay? So let's look at number 7. Be able to prove two statements are logically equivalent. Woohoo, we already did this. Look at me going ahead of the game. So look back at Tuesday homework. If you aren't confident, just redo your homework. Okay? If you aren't confident, just redo your homework. Just copy down the question, new page. Don't look back. Okay? Try it. Don't cheat. Don't go back and look and be like, oh, I wonder, I want to make sure I'm right. Don't do that. Just try. Try to do it by yourself, okay? Go back. Clean slate. Work through it. And then go back and look at whether you're right or not, okay? So this, and then I also make this note about our truth table. The truth table itself is not enough. You need something to wrap it up at the end. This is exactly what I have up here. So we kind of already did this. We went through the truth table. We went through what the sentence is at the end to wrap it up. So I'm not going to do that again. So this is, C number 4. Right? 4? Cool. I know how to do numbers. So write a biconditional sentence. Fill out a truth table. With each truth value, explain your reasoning. You could reference your biconditional sentence as an example or use the textbook definition of a biconditional sentence. So, when doing biconditional sentences, I think it's really easy to do it with math. Bring in just very simple algebra. Let's go 3 plus x if and only if x, maybe I should set it equal to something, is equal to 5 if and only if x is equal to 2. So we could also write this 3 plus x is equal to 5 if and only if x is equal to 2, or one more way, 3 plus x, is equal to 5. This double arrow, x is equal to 2. So I've given you 3 ways to write it. So this is our biconditional that we're going to use. So remember the truth table. The biconditional is correct when they both have the same exact truth value. So if they're both true or both false. So that is one way where you can explain. That's like the textbook definition. So you could say, same truth value, different truth value, different truth value, same truth value. Okay, that's totally cool. I'm good with that. You could also think about it in oh my goodness, you could think of it in mathematical terms. So we know if that we have 3 plus x is equal to 5. If and only if x is equal to 2. So we can make a string of biconditionals where then x is equal to 2. Okay? Because we're just, we're subtracting 3 from each side. Okay? So if I have this statement here, if I create this same exact string of biconditionals with the if and only if, but I'm saying that x is not equal to 2, so we could say, we come to the same conclusion, we could say but x is not equal to 2, thus we have a contradiction. If you ever come across a contradiction like this in the math, then you can go ahead and say that it's false. We do the same thing up here. So 3 plus x does not equal 5. So x does not equal 2. And then you know what we could do? We could just use this exact sentence. But we just changed the but x equals 2, thus we have a contradiction because the x equals 2 is true and it's false here. So you see kind of where we're going with this. And if they're both false, could have something along the lines of what we have here. So this statement is, you were negating our original statement. And then we can have, we know that x is not equal to as well. We know x is not 2 because it's false. Thus, confirming the truth value as true. So, anything like that. Whatever you guys are thinking as reasons, it's probably good. Just write it down. Like these reasonings that I'm coming up with down here are completely on the fly. I haven't thought about that too much, especially with this last one and how this works. But it does make sense. So the reasoning, just explain yourself, and if you're not comfortable drawing these more mathematical conclusions yet, I would stick with your textbook definition, where if you have two of the same truth value, you're going to have true, and if you don't, they're going to be false. So, inductive reasoning. So find the next term in the sequence, state or describe the pattern. So we have 1, 4, 9, 16, 25. I know that the next is going to be 36. These are just, it's like n squared. Okay? So n is the number of term and you square it. Very simple. This one, I noticed 3, 9, 27. I know those are all factors of 3. Okay, so we're just multiplying 3. Multiplying 3. So our next term is going to be 81. So we're just times 3 everything. So this next one, we have 111, 111. So every other term other term is 2. And then we just have a number where the subsequent place is being increased. Oh man, how would you even word this? It's interesting. You're essentially adding a 1 onto the... Oh, there we go. We're adding a digit. There we go. Adding 1 to the digit. There we go. That makes sense. Okay, what do we got here? 1, 4, 3, 6, 5. Okay. So I'm seeing a plus 3 minus 1 plus 3 minus 1 plus 3. So our next term is minus 1, so we should have a 7. So we have plus 3, then minus 1, and then this repeats. So we have dot 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 for repeating. Oh geez, this looks interesting. So we have 0. Oh, this is fancy. I love this. This gets into number theory and crap like that. So we have 0, 1, 1, 2, 3, 5, 8, 13. So our next one's going to be 21. And it's going to be the sum of previous two terms. Think about starting here. The sum of these two is 1. This is 1 plus 1. This is 1 plus 2. This is 2 plus 3. This is 3 plus 8. This is whatever it is, 5 plus 8. And then this is 8 plus 13. Okay? So this is some of the previous two digits. This gets into number theory and stuff like that. Pretty interesting stuff. I don't know if we actually get there in this class. I hope we do. So this looks like a string of even numbers, and every other one is negative. So this is just negative 12. Even numbers. Every other term is negative. This negative starts with 2, goes up. So it's just all the even numbers going up. Oh, what is this? Okay. So looking at this, I haven't even seen this one before. So I'm going to walk you through my exact thoughts and what I think. So what I do with these is I just start adding things. So it's thinking plus 2 minus 1, then plus 3 minus 1, plus 5 minus 1, plus 9 minus 1. So do I see any pattern there? 2, 3, 5, 9? Not necessarily. Oh, but I do see something better. I see that this is times 2. 3 times 2 is 6. 5 times 2 is 10. 9 times 2 is 18. So it's times 2 minus 1, times 2 minus 1, times 2 minus 1, times 2 minus 1. So this would be 34. So we're going to have a times 2, then minus 1. Okay? So that's that. So this is the note I make at the end. Remember that this is a study guide. It is meant to guide how you prepare for the test. I've listed every single topic up at the top that can and might appear on the test. Some of the questions are going to be in a different format or an unfamiliar format. That's okay. It's expected. If you prepare and understand the material and you actually know what's going on, you don't just memorize examples, you know how to do them, you will be able to succeed. Like I say, I have full faith in you. I've said it before, I'm going to post a video on this. This is going to be a long one. Thank you for watching. Yeah, look at your notes. Look at the packet that I'm going to pass back tomorrow from last week. Some of it I made some notes on. I X'd out some things that are wrong. And then just review some homeworks. And lastly, good luck. Remember, I will be here after school Thursday and before school Friday. Okay? So, if you have questions, please come in before school. My free periods are 1, 5, and 9. The next 2 days, just pop in. I'll try to be there as much as I can. I usually run 1 or 2 errands during them, so I probably can't be there the whole time. Anyway, that is all I have for you today. Good luck with your studying.